Hello student. Hello student of class 7. Once again I am Sudhi and welcome back to my video. In today's video I will show you the continuation of the exercise 12.3. The last two questions are there, 9 and 10. So I am writing the question number 9 here. Let us see what the question number 9 is telling us. What should be the value of A? What should be the value of A if the value of x twice x square plus x minus a equal to 5 when x is equal to 0. Means we are going to take the value of x as 0. Okay, and here they gave us an equation. The equation is twice x square plus x minus a equal to 5. So we have to take this equation and we have to find out the value of a. Okay, x value is given here as x value is given is there as 0, and now we are going to find out the value of a. X value is already given. See, in this expression there are two variables. Okay, there is one x and a. X value is given here as 0, and now we are going to find out the value of a. From this equation, there is twice x squared plus x minus a equal to 5. From here we are going to find out the value of a. So it implies that 2 into 0 into 0 square means 0, isn't it? Plus x get 0 minus a equal to 5. So my dear student, we know that here this whole part will be 0. Anything multiplied with 0 will be 0, isn't it? Then plus 0 minus a will be minus a. Then 5. Now implies that next what we have is that 0, nothing is there to write now, plus and minus. Okay, so we are going to change the sign here. We are not going to change the sign here in the bracket, so we will take the sign in the bracket for there is plus outside the bracket, isn't it? So minus a is equal to 5. That means a is equal to minus 5. Okay, a is equal to minus 5. So we are going to find out the value of a only. So the value of a is now we get as minus 5. See here minus a is equal to 5. We are going to find out the value of a, not minus a. Okay. So you can put the minus on the other side. How we can put that I will tell you like this. Minus a into minus 1 equal to 5 into minus 1. So if you multiply both sides with the same number, that's going to effect on the value, isn't it? So we can multiply it here, minus 1. So if you multiply minus 1 and minus a, you will get plus a. If you multiply 5 and minus 1, you will get here minus 5. That's why the a value of a is now we get as minus 5. Right. Now, hello student, next we have question number 10, and question number 10 is saying that simplify the expression and find its value when a is equal to 5 and b is equal to minus 2. So the given expression is here, it is 2 in the bracket a cube plus ab plus 3 minus ab. So this is the expression. We have to take this expression and we have to simplify. Why we need to simplify is that simplify in the sense that the given expression is incomplete. So we have to be complete by opening the bracket or by carry on some of the operation. Okay, this is called simplify. So let us see how we can simplify. The given expression is 2 into in the bracket a cube plus ab plus 3 minus ab, isn't it? So now when we simplify, we get here like this: 2a cube plus twice ab plus 3 minus ab. So what happened? My dear student, you can see here twice a cube plus twice ab minus ab. They are same term, like terms. Okay, so we can do one more operation here with these two terms. That is, we have to subtract 1 ab from 2 ab, isn't it? That is twice a cube plus ab plus 3 we are getting here. So the simplification or simplifying is done here, and now we are going to find the value. Now we have like this: twice a cube plus ab minus 3 So we are going to find out the value of this expression. Now, when a is equal to 5 and b is equal to minus 3, then 2 into 5 into 5 into 5 plus AB. A is 5 and into minus 3. B is minus 3. Then minus 3. So this is what we are going to get now. Okay. Now let us see. 5 is 3 times because as a cube means we are multiplying a 3 times here. Yes, so that means 5 is multiplying 3 times here. So let us find out if you multiply 5 3 times, how much you are getting here? You are going to get here 2 into 125 plus, okay, in the bracket, minus 15 plus 3. Yes. Then let us see. Hello, I just played now little changing is that this is not cube, it is square. Okay, here also must be square, here also must be square, here also must be square, here also must be square. Okay, so now we get the simplification, or we get this simplified the expression now. After we get the simplified, then we are going to find out the value, isn't it? Now the value of this expression twice a square plus ab plus 3. Now implies that 2 we multiply with 5. With 5, isn't it? Square means a square means a into a means 5 into 5 plus 5 into minus 3 plus 3. Yeah. Now if we multiply these two, how much we are getting here? 5 times 25, 25 to the 50, isn't it? Yes. 50 plus, if you multiply these two, you will get here minus 15 plus 3, isn't it? Then you see, if you open the bracket, you get here minus 15 plus 3. So plus 3 and 50, if you add, you get here 53 minus 15. That is equal to 38. So 38 is the answer we get. Okay, clear? The value is 38. Okay, so please note down, and this is the question number 10. No? And here, this is question number 10. Okay, this is the question number 10 of the exercise 12.3. And this is the last question. So now with this, we will go to the next exercise. Okay, so please note down this. Hello student, next we have exercise 12.4. In this exercise 12.4, question number 1 is about to find out some unknown numbers of the petals. Okay, and some kind of designs are there in the electronic watch, isn't it? How the numbers are designed. So whatever the numbers they design in electronic watch, they are made up of equal segments. 0 you see, 4 segments are there, 8 you see, 3, 6, 8, 3, 6, 7 segments are there, isn't it? And you see number 6, this number 6 that you find in the electronic watch. So it is made by different segments. Equal segment 1, 2, 3, 4, 5, 6. 6 segments are there to make this number 6. This is number 6, isn't it? So if you want to continue in such a way that 1, 6 is there, isn't it? Like this, like this, like this, like this. Another 6. Yes, yes. 1 here, 1 here, another here. So we continue like this to make the digital 6 with the same segments. 1, 2, 3. 3 patterns are here, isn't it? And so on like this. For example, here it is 1, here it is 3, isn't it? Yes. So see, if you want to make the number of patterns, okay, we don't know that number, how many numbers. So what happens? We will take n. Okay, n. N is number of pattern. 1, 2, 3, 3n. N is equal to 3. Here 1. N is equal to 1. N stands for the number of patterns. Okay, clear? And this pattern is made by same segments. Segment means small lines are called segments, isn't it? So by same segments, so how many segments are required? Then we can find out with the help of this algebraic expression or the concept of algebra. With the help of the concept of algebra. So now let us see, if you want to make a a certain number of patterns. So let us say n number of patterns equal to 5. Okay, 3. How many patterns are there? We don't know. 1 is 6. For 3, how many patterns are there? 3 patterns are there. How many segments are there? We don't know. We have to count. Okay. If number of pattern is 5, this type of pattern is 5, how many segments are required? We can see. So first of all, what we have to do is we are going to make an expression here, algebraic expression. Okay, 1, 2, 3, 4, 5, 6. Isn't it? That means for pattern 1, it is 6 segments are there. 6 segments are there, isn't it? So what happens if you continue in just a way that all are joining and having 1 as a common here. One segment common here. You can see for this 6, for this 6, 1 is common. So what happens? One segment. 6 segments are required, isn't it? 6 segments are required to make one pattern, but if you make 2 patterns and one segment is common, then 1 you minus from 6. 6 minus 1 is equal to 5. Take this 5. Okay, so we'll take this 5 and we'll write 5 into number of patterns n plus that 1 is removed and this is in common of 2 consecutive patterns, that is 1 segment is common, that we add here. Okay, 6 reduce 1. Why? Because 1 is neither for the other for this one. Okay, so this 1 is common, this 1 segment is common, so you count it 1, 2, 3, 4, 5. Then get 5 and into with n is number of pattern, 3 or 4 or 5. Okay, and then you plus 1 here. Why we plus 1 here? We plus 1 that number of segments that is in common. That how much segment is common? Then we will add here. Plus 1 or plus 2 or plus 3. Okay. How much they common? Okay. Now you see here, we got here how much? 5n plus 1. So 5n plus 1 is the formula or the expression to find out the number of segments as per the number of patterns here. So number of segments, we know that it is 6, but if it continues, this is the way that 1 is common, then we will take 5n plus 1. 5n plus 1 is the formula or the expression to find out, okay, the number of segments according to the number of patterns. So if we are going to find out the number of patterns are 5 there, how many segments are required? So we can find out that n is equal to 5 plus 1. That is 25 plus 1, that is 26 segments are required. 26 segments are required here now, isn't it? In the same way, let us find out for this pattern, 3 patterns are there. N is 3, isn't it? So we'll take this formula here. It is 5n plus 1 implies that 5n means 5 into 3. Now we get this n is equal to 3, isn't it? Yes, n is equal to 3. We are getting here n is equal to 3. So n is equal to 3. So n means 5 into 3 plus 1, that is 15 plus 1, that is equal to 16. 16 segments were required now to make 3 patterns. Okay, just 2 patterns. So let us say how many are there? 16 or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes, 16 segments are required there to make 6 patterns. So the important thing is that how to make the expressions to find out such sets or such patterns. Okay, clear? So let's go to the next B, the pattern number B. Okay, in B also you will get a pattern which you can see in the digital box. Okay, that is 4. 1, 2, 3, 4. Right. Then 1, 2, 3, 4. For one pattern, this is one pattern, isn't it? One pattern, n is equal to 1. Number of pattern. N is number of patterns, so n is equal to 1. Now you see here, if you make two patterns, here one here, another here like this. Then here n is equal to 2. Two patterns. And if you want to make three patterns, one segment, two segment, three segment, four segment. For other, one will come in here and here, isn't it? Another one also will come in here, will make here. 4. So n is equal to 3. And like this, if n is equal to 6 patterns you want to make. So you can here you can count the segments here, but if the segments also not given, if you want to make the 6 pattern, how many segments will be given? We can find out with the help of this concept of the algebraic expression. So how to make the expression that we are going to discuss. Now see we have for one pattern, 1, 2, 3, 4. Four numbers of segments. 4 segments are there, isn't it? 4 segments are there, or 4 small sticks are there. 4 segments or 4 small sticks are required here. 4 segments are required. Okay. And for this, n is 2 means for this that number of patterns are 2. 2 patterns are there. Then how many are there? 1, 2, 3, 4, 5, 6, 7. 7 segments are required. 3 we can count. Okay. So, but instead of counting, how you will find out such unknown here, isn't it? Unknown segments when you want to make 6 patterns there, or 7 patterns, increase more and more. So there is no time to find to count also. So, but there's a very simple and easiest way to find the number of segments. There is we are going to follow the algebraic expression, isn't it? Yes. Now we know that n is a number of patterns. Now here consider here is first pattern. How many numbers are there? 4 are there, isn't it? 4. So what happened? We are making the pattern in such a way that one segment again will come, isn't it? So for this 1, 2, 3 you count, isn't it? And 1 is common. For this 1, 2, 3, and then 1 will come here, isn't it? That means instead of 4, you will take 3 here, 3 and you multiply with n, 3n, and plus how many segments are common here? Only one segment is common, so that means 1 will be here. 3n plus 1. Then this is the algebraic expression to find the number of segments for every pattern. Okay. So let us see. Here n is 3. Now when n is 3, when the pattern is 3, then let us see how much segments are required there. See, you know 3n plus 1, isn't it? 3n plus 1 implies that 3n means 3 into 3. 3 patterns are there plus 1. That means 3 is 9, 9 plus 1 means that is equal to 10. 10 segments are required here in this case where 3 patterns are there. So let us count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, 10 segments. So 10 segments are there. Okay. And then now next n solutions. If you want to make 6 patterns, then how many segments are required? Let us see. There is 3n plus 1 implies that you take this same formula, right? Yes, formula or the expression. Okay, to find out the number of segments. Now we see here 3n plus 1. That means let us say 3 into n is equal to 6, then 3 to 6 plus 1. That is 3, 6 and 24 plus 18. 18 plus 1. 18 plus 1, there is 19 number of segments are required to make this pattern continues. Okay, pattern. What is this pattern? This pattern is the number 4, isn't it? Yes. This. And now let's go to the next C. Okay. Another pattern also given there in C. This tools and copy down. Okay. You remember in your notebook. Now number C. Number C, you see here is digital number 8. Okay, digital 8. 1, 2, 3, 4, 5, 6, 7. With the 7, with the 7 segments, you will get that pattern of 8 in digital clock or digital notes. Okay. Here, how many segments are here? Now, n is 1. Isn't it? N is 1 and number of segments is 7 segments are there. 7 segments. 7 segments are there, isn't it? Yes. Now you make such pattern continues like this. Yes. 1. 2. Now n is equal to 2 now. How many patterns? 2 means will it be 14 or some other? Yes. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Instead of 14, we got in 12, isn't it? Yes. So what I'm going to see, when you make the pattern instead of the continuously and they say two segments in common, okay, two segments are common. So for this, we first one pattern here, this first pattern, only 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 5 already come here. Here also 1, 2, 3, 4, 5. And these two are common in between two consecutive patterns, isn't it? So how many segments are common there in two consecutive patterns? Two segments are common. Therefore, what happens here also we can try another case here where n is equal to 3. Okay, n is equal to 3. Yes. When n is equal to 3, the number of patterns is 3. You see 1, 2, 1, 2, 1, 2. So among two consecutive patterns, two segments are in common. So whatever that 2 is minus from 7 by getting 5. Take this 5 and make that expression, not equation, okay? Expression, it is 5n plus, which we have minus or which is in common. The number of segments common is 2, so plus 2. So we have to take this expression to find out the number of segments for certain number of patterns. Now say for 2, n is equal to 2, then n is equal to 2, so how much segments are there? Let us say equal to 5 into 2 plus 2, that is 10 plus 2, that is 12. 12 segments are required. Yes or no? Let us say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 patterns are. Now for this tree, let us see how much are there. We are going to take 5n plus 2, isn't it? Yes. That equal to 5n plus 5n, how much? 5n will be 3 plus 2. 5 3s are 15 plus 2. That means how much? 17 seconds are required. 17 seconds are required. So let us see how is it 17 or not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yes, 17 number of seconds are required for this 3 patterns, 4 patterns, 5 patterns, 6 patterns. Carry on. That's all. For this n number of patterns, we will get 5n plus 2. Okay, so this is one. So with this, please get the answer of this question number 1 asking below the question. In the last part of the questions, they are asking some pattern, some number of patterns are there. Okay, for the same 7 digital numbers like 6, we have discussed about 6, 4, 8. Isn't it the same? Ask of different numbers of patterns. So please give me that answer. Okay. Now with this, let's go to question number 2. Okay, students, I will just complete this question number 1. Okay. So question number 1 is asking you that how many segments are required to form 5, 10, 100 digits. Digits of the time. Okay, 100 digits. So we are going to find out n is equal to 5, n is equal to 10, n is equal to 100 for such kind. Okay. So first one you see in the first case A. In the case A, we get this. The expression is 5n plus 1, isn't it? That means if it is 10, the 10 time of the pattern. Okay, then 10 time of the pattern, then we get 5n plus 1, that is equal to 5 into 10 plus 1, that is 50 plus 1, that is 51. 51 segments will be required, isn't it? Then again it is 10, fifth. Okay, fifth. Then I show here fifth. Fifth. Then for fifth, you will get here 5n plus 1. That is 5 into 5 plus 1, 25 plus 1. That is 26. 26 segments will be required, isn't it? Yes, for fifth. And for 100. 400. Okay, 400. 5n plus 1, that is 5 into 100 plus 1, that is 500 plus 1. So we got here 501 seconds equal for such 100 digits of 6. And 5, 10, 100 digits of this button, 5, 10, 100 of this. We have to find it, isn't it? So like this. So again, yeah, this is for the A, first one, isn't it? So second, in the case B, what was the pattern there? The pattern. So in the case B, the pattern was 3n plus 1, isn't it? 3n plus 1. So that means for fifth, okay, this 3n plus 1 equal to 3n means 3 to 5 plus 1. That is 15 plus 1, that is 16. And for the 10, how much we are getting here? 10 means for 10, 3n plus 1, that is equal to 3 into 10 plus 1, that is 31. And for 100, that is equal to 3n plus 1 equal to 3n, means 3 into 100 plus 1, that is 301. Okay, yes. That is for this last one, please do yourself. Okay, come to you now for this pattern. The expression is already given there, 5n plus 2, isn't it? Apply the expression and find out how many segments are required for such number of digits in case 3 or in case C. Okay, and let us go to question number 2, please. Hello my dear student, now we have question number 2, and question number 2 is given the question as in the form of a table. Okay, so I just take some formalities of the table. You see here, serial number 1, 2, 3, 4, 5, 6 up to 5 serial numbers are there. So I'm taking out this serial 1 and serial 4. Okay, in serial 1 is given the expression and the end. This is the end. Okay, they are the end. Okay, these are the end. These are the end. First, second, third, fourth, fifth. N number of pattern. N number of patterns. Second number, third, fourth, fifth, sixth, up to 100 there. Okay, clear. So you are going to complete. For all this, n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5. That's completed because n is equal to 10 is completed. Now for this, you have to complete n is equal to 100. Okay, so here n is equal to 100. So now let us see this one. And here for this serial number 1, the expression is twice n minus 1, isn't it? So twice n minus 1. So n here n is equal to 100, isn't it? So 2 into 100 minus 1, that is 200 minus 1. How much is that? That is 199. Is the answer here 199, isn't it? Yes. Next, you see here in 104, this n1, n2, or n is equal to 1, n is equal to or 3, 4, 5, all given here. For the given here, for 9, for 5th, 10, and 100, we are going to find out the value on this expression, isn't it? So let us see. So first of all here for this, now expression is 7n plus 20, isn't it? So for this fifth one, here n is equal to 5. Now 7n plus 20 equal to 7 into 5 plus 20. 75 is 35 plus 20. How much will be here? 55. So here we got here 55. Okay. Yes. Then here n is for how much? N is equal to 10. Isn't it? Then 7n plus 20. How much will be getting here? Equal to 7 into 10 plus 20. That means 70 plus 20. That you will get as 90 here in this end. 10. Okay. Then here n is equal to 100. So 7n plus 20 equal to 7 into 100. This is 100, okay. Plus 20, that means 700 plus 20, that will be here 720. This is the answer, 720. So this is the answer we are getting, okay. So my dear students, this is the answer for about serial number 1 and serial number 4. So some other serials are there that you complete yourself, okay, from the channel, okay. I hope that you all understand. So please check once again this. And my dear student, with this we come to the end of today's session as well as the end part of this chapter number 12. So in chapter number 12 we have discussed about the algebraic expression. So what is the algebra? Algebra is a section of mathematics studies where we deal about some unknown values which is represented by variables like alphabet letters A, B, C, X, Y, Z. Okay, clear? So we know what is the term of the algebra, isn't it? And what are the expressions and how do the terms are formed, how do the expressions are formed. We have discussed all this in this chapters. So statements are given and we are going to write the expression. Expressions are given, we have to convert this into the statement. So like this we have discussed in these chapters. So here the most important things you have to remember is that what is the coefficients? The coefficient is that the core number with the alphabet or with the numerical. So in terms, there are two parts of the algebra. Okay, in algebra there are two parts of the terms. One is called the numerical coefficient and another is called the natural coefficient. Okay, natural coefficient is represented by the letters and it is the unknown value, and numerical coefficient is the number and which are having fixed. So terms are also two types. One is called the variables and one is called the constant term. Variables are the number, or the variables are the terms. Variable terms are the terms that used to combine with the number and letters, and constant terms are the terms which is only with the numbers. That means our natural number. Okay. So hope that you all understand the chapter, and if you have still doubt and have many questions to ask, please don't forget to call me my number, and you can drop message to my personal WhatsApp. So every time, anywhere, and anyhow, you can get a contact from me to discuss about this chapter number 12 or the other stuff. Okay. So with this, have a nice day all of you, and take good care of you, and thank you once again for watching my video. Bye bye.